So, welcome to module P1. So, this is nothing but we are going to have a set of modules specifically dedicated for projects. So, we will explain certain concepts that will help you to quickly finish the projects as a set of under these module P1, P2, P3, P4, as and when we feel that there is a necessity for giving some extra input specifically for the project, we will basically do it here. So, this P1 basically we are trying to give you some inputs related to your project 01. So, when you had downloaded NAND to Tetris, you would have got two directories, one is called tools, another is called projects. Both will be in a directory called NAND to Tetris. Now, you can go into projects, there you will find 00 which is just a file, then 01. Now, you must be doing this 01 now, and we will explain certain concepts of 01, certain concepts which will help you to complete 01 faster, right. So, one of the interesting thing is that as we are doing 01, you would have realized that there are things like you were having NOT 16, where you are handling 16 wires at a time and you are getting 16 inputs at a time given to these wires, each of them knotted, and you are going to get 16 outputs, like that multi-bit gates, multi-way gates. So, now we are seeing we are trying to process a vector of inputs, not single wires, but a collection of wires, a vector of wires, right. So, that is very very important. Now, how do we transfer one vector of wire to another gate? Like let us say this NOT 16 is giving me 16 bit output, right, because there will be 16 wires. This 16 bit again I have to pipe it to some other gate. So, how are you going to do all these passing on? So, that we will do with the help of 3 examples, very quick examples, which is also part of your project 01, right. Let us see first one. This is mux, right. How do you write a mux? Mux is given AB, given A and B and select. We basically have to if select is 0, you output A, otherwise you output B. So, this is written. So, mux is done, in which there are 3 inputs A, B and select, and out is the output. So, if select is 0, output is A, else output is B. Now, using this we want to make a mux 4-way 16. 4-way 16 means I want to basically construct a 4-way mux to start with. What is a 4-way mux? A 4-way mux is that I have A, B, C, D, and basically I have 2 select inputs, select 0 and select 1, and this is out. If these 2 bits are 0 0, I get this 0 1 1 0 1 1. So, when if this is 0 0, out equal to A, 0 1 out equal to B, out equal to C, out equal to D, right. So, this is what we call as a 4-way mux, right. Now, I am now talking of mux which is 4-way and 16 bit. Essentially, this is one structure, let me call it, this is a 4-way mux that takes 4 inputs and gives me an output. So, I will replicate it 16 times, that is a mux 4-way 16 bit, right. So, I give A0, A1, A2, A3 here, or sorry A0, B0, sorry, I give A0, B0, C0, D0 here, like I give A15, P15, C15, D15 here, and the select is common to all, and I get out 0 to out 15. We have explained that earlier. So, this is a mux 4-way 16 bit. Now, I could also have mux 8-way 16 bit, wherein I will have cell 0, cell 1, cell 2, and then I will have 8 selections here. So, A, B, C, D, E, F, G, H, depending on 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 till that 8. So, now what we will see here is mux 4-way 16, right. Okay. Now, how do we do this 4-way 16 bit multiplexer? We just do a 4-way 1 and repeat it. So, now essentially what we are doing here is that mux A equal to A0, B equal to B0, cell equal to cell 0, out is T01, A equal to C0, B equal to D0, cell equal to cell 0, out equal to T02, and so on. So, what we want to demonstrate here is that you see cell is a 2-bit input that is given to you. Cell is a 2-bit input given to you. A, B, C, D are 16-bit inputs that are given to you, and out is a 16-bit input. Now, as you see, I want to basically do this mux, as you see here. This is a mux which basically takes A0, B0, C0, D0, cell 0, cell 1, and basically gives me out 0. How do we do that? This is as follows. So, what we need to understand here, we have already seen how to do a 4-way mux from a 2-way mux, but what we see is how we are going to basically pass the inputs. So, I am putting 3 muxes here. So, suppose I want to do this A, B, C, D, cell 1, cell 0, out. This is nothing but do A, B, do C, D, both with cell 0, and then take this output, do it with cell 1, and you get out. So, now this has been shown earlier. So, this 4-way mux can be realized using 3 2-way muxes, and that is precisely we are doing here. As you see here, precisely what we are doing here. So, as you see at this part, so mux A, the first one will take A0, B0 and cell 0. So, the first line that we are seeing here is corresponding to this particular mux that we need to see here. This is a particular mux here, right. A0, B0, cell 0, out is some T01. This wire, whatever I am marking in green, is T01. The second mux you see here, takes C0, D0, again cell 0, and out is T02. The third mux you see here takes T01 and T02 as inputs, and cell 1 as the select, as you see here, cell 1 as the select, and out is. So, this particular 4-way mux, we are now replicating it 15 times. What you need to understand here is that for the first mux, A0 is the input, for the second mux, for A0, B0, C0, D0, and cell 0, cell 1. So, I can take, so I have declared a 16-bit input here and a 2-bit select here, many 16 bit inputs and 2 bit select, I can basically take part of those inputs. This is called part select, or we can also say bit select. I can take individual bits of those values and assign them to construct this. For example, I am taking one of the 16 bits of A, similarly B, C, D, one of the select bits here, and I am also assigning output to one of the output bits here, only out 0, and I replicate it. So, this is how we can build a, we are building a mux 4-way 16 from a normal mux. Now, the next thing is, so here what we have done, we have taken vectors and basically assigned them, we have taken vectors as inputs and basically taken bits from each of these vectors. So, A0 is one bit of A16, B0 similarly B0, cell 0, etc. So, we have taken one bit and we are able to separately assign these bits to some inputs and outputs. So, this is one thing that will help you quickly understand and do the project. The second thing that we would like to show here is the 8-way 16 bit mux. 8-way 16 bit mux, right. So can be easily done here. So, what we do is, how do we construct an 8-way mux from a 4-way mux, right. Let us say this. So, this is a 4-way mux. So, how do you construct an 8-way? The 8-way can be basically constructed as one 4-way, another 4-way. So, I will have A, B, C, D, E, F, G, H, and I have cell 0, cell 1, cell 0, let me call it S1, S0. Then we take this, so each will give me two out, so one output, right, and I give it to a 2-way mux, and this will be S2. So, because you have 3 select bits, it is 8-way means, 4-way means you have 2 select bits, 8-way means we will have 3 select bits, S0, S1 and S2, and this will be your output. So, if I get 0, 1, 0, 0, 1, 0, 0 is 4, E will go there, 0, 0, 0, A will go there. So, this is how. So, I can take 2 4-way mux and get this, and 1 2-way mux to get the 8-way mux done. So, that is precisely what we are doing. So, if you look at this, right. So, if you look at, if you look at this, right. So, the first I am using one mux 4-way in which A, B and C and D are taken, and I am taking the first 2 bits of select, select 0 to 1. This is called part select. Select is a 3-bit, but I want to use select 1 and select 0 here. So, what this mux, what I am doing, this mux 4, this thing, I am basically using this part, this mux, and for this mux I am using only select 1 and select 0. So, I need select 0 to 1. Similarly, for this mux, again I am taking select 0 to 1 and EFGH as input, and then of course, you get the next mux takes the out of the first and out of the second and takes only the select 2 bits. So, now this is not just mux 4-way, but it is a 16-bit mux, 16-bit mux 4-way. So, if A16, I just put A equal to A. Please note that in mux 4-way 16, again I have a 16-bit variable. So, all the 16 bits automatically get assigned, right. And we are also taking a part of that select. Select is 3 bits as you see here, but I am only taking part of that select. So, I could also take 2 bits like that, right. So, this is another very important thing that we need to keep in mind. This is called part select. In the previous thing, when we saw the mux 4-way 16, please note that we were using only bit select, we are taking only one index here. But when we are looking at the next one that we are showing here, namely your mux 8-way, please note that we are taking part select, that is 2 of the 3 bits. So, this is the syntax that you can do. So, select is assigned those 2 bits. Very interestingly, if you also use this out1 and out2 are intermediate wires that we have created. Now, this is 16 way mux. So, this out1 should be 16 bits, out2 should also be 16 bit. They automatically become 16 bits because I am assigning it to out, which is defined as 16 bits in mux 4-way 16. In mux 4-way 16, the output variable is 16 bit. So, when I assign out1 to out, automatically out1 also becomes a 16 bit variable. So, that is very important to note. So, suppose I want to generate this 16 bits, just put out equal to out1. Since out is 16 bit, out1 is also assumed to be 16 bits, it becomes 16 bits. Similarly, out2 becomes 16 bits. And now I say A equal to out1, B equal to out2, all the 16 bits here gets assigned to A here, and all the 16 bits gets assigned to B here, and then use the select, 1 bit of the select to get the out here. So, the first 2 4-way 16 will give me 2 outputs, out1 and out2, each will be a 16 bit output, that I am going to put here, and depending on the next select I am going to get which of those 16 bit I am interested. So, this is how we have basically constructed, as you see, 3 muxes. First mux will give me one of the first 4 A, B, C, D, but 16 bits of them. Second mux will give me E, F, G, H, in this case 16 bit because it is a mux 4-way 16 bit. The 2 16 bits are put into another mux 16 and with 1 bit it will select which of those 16 bits it is going to take. The point to note here is that the part select, I can select a part of your entire index, and of course we have seen bit select earlier. So, these are things which will quickly enable you to complete the project. So, you will have lot of queries, and all these queries do put back in as a feedback in the discussion forum, and we can encourage discussion to actually help you do the project. I hope this lecture, this particular module has basically clarified some of the important inputs on how do we start sending data inside. Okay. So, this is very important. Okay. The next thing, the last thing I want to tell in this module that would be of useful to you in the future also in this particular thing is that how do we generate say 0. Suppose I have a bit, I call it say P. Suppose I have a wire P which is a bit, if I say P is equal to false, essentially that means P is assigned 0. If I say P equal to true, all smalls, then P is assigned 1. Suppose this P is not a bit, but it is like what we call, right, A16 or something, and I say A equal to false, whatever reason, then A15 to A0, the entire, all the bits are assigned 0. So, this essentially becomes 0, 0, 0, 0. If I say A equal to true, then each of these bits become 1. So, I get 1, 1, 1, 1, 1, 1, 1. So, if it is a single bit P equal to false, that single bit becomes 0, P equal to true, that single bit becomes 1. But suppose I have a thing like A16 and I say A equal to false while passing, so this will be while passing some parameters into the design. When I say A equal to false, all the bits become 0. If I say A equal to true, all the bits becomes 1. So, how will you generate a 0? right. Just say A equal to false, it will become 0. How will you generate a 1 for example? Suppose I say A equal to true, so let us say each is 16-bit variable, A equal to false will make A15 to A0 all as zeros. Now A equal to true, if I say A equal to true, then A15 to A0 all will become 1. So when I add A with A, what do I get? Say let me say 4 variables, say 8 variables, A with A, I get 0 0 0 0, sorry, I get 1 1 1 1 1 1 1 0, right. So when I invert this, I get basically so the way I can generate 1 is take any 16-bit variable, first make it true, so all the 15 bits will become 1, add it with itself, then you will land up with a value in which the least significant bit is 0 and all the things are 1. Now I invert this, so I get the value 1, right. This is how we can generate constants like p equal to 0, p equal to 1, etc. So these are all some things which would be very important. For example, we will be asked to do an increment, right, increment, a 16-bit incrementer, where given some A, you are supposed to return A plus 1. Now how do you do this incrementer which will increment it by 1? How do you do that incrementer? So again, so things like this can basically come up in a good way, right. So this is something which is very interesting as far as the project is concerned. With this level of input, and if you start working, I am sure you will cross the barrier of project 1 that you need to complete. Thank you.